Hello and welcome to this WebEx video presentation for the Temple University NASA Lunobotics electrical team of 2014. This is the WebEx posting that is due Friday, February 21st, and my name is Mark Halberstadt. I'm going to be, going through this WebEx posting. It's the second WebEx posting of the spring semester for Senior Design 2. So in this presentation, what I want to do is I want to go over the electrical team goals, talk about the overall progress we've made, and then also discuss the next steps for the project. So our team goals, as always, they really have not changed. Our primary goal is to design and build power control and communication systems capable of driving a mining vehicle through a harsh lunar environment. And as I said in the last video, we have made significant progress toward achieving this first goal. This past week, we have made advancements with our manual control system, which makes our manual control system much more responsive, and that's going to really go towards implementation of this goal. Our second goal is we want to achieve complete autonomous function. We have made progress here, some of which I am going to go over in this video. We still have got a bit more work to do on our autonomous function. Our third goal is to increase the power efficiency such that we can reduce the size and weight of our battery system. We have made some pretty good progress on this third goal this week on our power monitoring system, which I'm going to talk about. So our overall progress, as I guess I kind of mentioned earlier, we have implemented a power monitoring system. I'm going to be showing you a video demonstration of that. The power monitoring system is able to log data out to essentially it's being exported into a text file from a Java program, such that reports on power consumption can be generated. And in addition to that, our power monitoring system actually makes it enables a user of the robot to monitor power consumption from an LCD screen that's attached to the robot. So anyway, I'll show a kind of a video demonstration of that. We have also implemented a first version of our Wiimote servo scanner system that is using a particle filter. I'm going to show a video demonstration of this. There's actually kind of significant work that needs to be done on this first version that I'll talk about when I show the video demonstrations. So to start off, let me actually start with a demonstration of this power monitoring system. So I'm pretty much going to start the video and allow the video to play through.
So here is the Arduino on the left. I have our voltage divider right here. Here's our, obviously this is the LCD. You can see the timer going. Just keeps on going, and obviously you can see it'll reset once it reaches 0, or once it reaches 59, it'll get to the next minute. So our timer's working good. Here is our voltage, current, power, and here's our watt hours. So that's the power measured in watt hours. So if I also have the sensor up here. So there's the current sensor all hooked up, and it's got a 25 ohm power resistor. So there it is. I'm going to turn on, or I'm going to close the circuit, so that way you get some current going through the power resistor, and you'll see the current and the wattage go on. So if you do the calculations, it's about 1 amp for a 25 ohm resistor, and you see it's hovering around 25 or so watts, and you can see the watt hours is incrementing. I shut it off. Current and wattage goes to 0, like they should, and your watt hours stop, and that should too. So that's pretty much it. That's pretty much everything for how to measure voltage, current, and power, and also get your power consumption with watt hours. So thank you very much for watching, and have a good day.
Okay, so that was the video showing our LCD implementation of the power monitoring system. And as the video explained, power is going, or the statistics on the power system, they're going to be displayed are our voltage, our current voltage output from the battery. Voltage output from the battery is about 25.9 volts. So this is a little bit higher voltage, but it's right about our expected output from the battery. We also get a display of amps being output from the battery, as well as watts by multiplying current and voltage together. And then we kind of keep a running tally of the energy output from the battery, of the energy consumed by the robot in watt hours. So anyway, that was our first video demonstration. Next, what I want to show is a video demonstration of the first version of our Wiimote scanner, Wiimote LED scanner system that uses the particle filter to locate the LED beacon. So I'm going to start playing this video, and actually I'm going to mute the audio here. And pretty much what you can see is an LED beacon is being held here, and it needs to be connected to the computer because the particle filter system is actually modulating this LED beacon. It's turning the LED beacon on and off. And then we've got a Wiimote center mounted on top of a servo. And then to find the LED beacon, it's a bit hard to see in this video, but a particle filter system is being used to locate the beacon. Based on the location of the beacon within the field of view of the Wii sensor, the particle filter system is going to tell our servo motor to rotate such that the beacon can always be kept in the field of vision. So I'll play this, and you can see the servo motor is rotating and basically following this LED beacon. So it's going to move the other direction. So there it's moving, the beacon's moving the opposite direction, and you can see that the servo motor is turning the sensor, and you can see the update here on the particle filter that is keeping the LED beacon, I guess, close towards the center of the Wiimote screen's field of vision. So this is the first version. And there are a couple of advancements that we've actually already started making. They're not complete yet, so they're not in the video. But the problem with this system, essentially, is that this works very well when there is no interference present in the field of view of the Wiimote camera. So it works very well when there is no interference. Once any type of DC interference is introduced into the field of view of the Wiimote camera, and that's really what the particle filter was designed to filter out. It was designed to filter out DC interference. As soon as DC interference enters into the field of view, uh, the particle filter continues to work, but it does not work when the sensor itself begins to rotate. So we are actually rewriting the algorithm that's going to be turning the servo motor. And basically what we have to do after we turn the servo motor is we essentially have to reset our particle filter and allow the particle filter to go through about 3 complete cycles of regenerating particles, such that if the beacon is in the field of view of the Wiimote, that we are going to be able to locate it while the servo motor is stationary. That's really what's going to have to happen. We're also implementing additional algorithms that are hopefully going to make finding the beacon much faster than we have in the past. In the past, what essentially happened was the servo motor scanned, kind of fanned outward from the last known position of the beacon, and it fanned outward in increments of about 4 degrees. We're actually increasing that significantly, where the fan out is going to go in steps of about 20 degrees. So it's going to go in discrete steps, and we should be able to locate the beacon much more quickly with this new implementation. So anyway, those are our 2 video demonstrations. Moving on, just to talk about the next steps. The next steps for the power system are to integrate this power system that I showed the video demonstration of into the first mechanical prototype and into our autonomous lawnmower testing platform. For our communication system, I didn't talk about too much in this video, but we have made some good progress on our communication system. The next steps we have for that are constructing Java packages specifically for the autonomous GUI system that's going to be in our command center, and also for our location system, such that the location system can communicate with the central controller. For our control system, we really have to finalize the particle filter version of the servo scanner. So we have to essentially improve and really perfect the operation of that Wiimote sensor mounted on top of the servo. So the important dates that we have coming up, February 28th is a Friday. It's a Friday before spring break. And by Friday the 28th, we hope to have completed a round of testing our autonomous system using our autonomous lawnmower testing platform. So that's still our goal, is before spring break. And then March 9th is essentially the end of our spring break. And by the end of our spring break, we're hopeful to have our final manual control system implemented on the mechanical prototype. And we also hope to have integrated in our autonomous system into the final mechanical prototype. So anyway, I guess that is it for this particular presentation. If you have any questions, please feel free to leave comments in either the YouTube video or the WebEx video, or you can feel free to email me at c.mark.halberstadt@temple.edu. Thanks so much for watching.